Hiya, welcome to the second part of this week's lessons. Let's start straight away with our 6 starter questions. The first one of which is, what is the vector for genetic engineering? 2, what is the role of the restriction enzyme within genetic engineering? 3, what is the role of the ligase enzyme? 4, define homozygous. 5, what are the units of work done? And 6, explain fully the formation of an ionic bond between a sodium atom and a chlorine atom. Okay, good. Let's go through our answers then. The vector for genetic engineering is bacteria. The restriction enzyme is used to cut out the desired gene and also to cut a hole within the bacteria plasmid. The ligase enzyme is then used to stick that desired gene into the plasmid. Homozygous is when you have 2 alleles the same. Work done is joules, it's a form of energy. And then the formation of an ionic bond. Well, the sodium atom's in group 1, so it wants to get rid of an electron. Chlorine's in group 7, so it wants to gain an electron. So sodium donates 1 electron to chlorine so that they both have a full outer shell. That movement of electrons creates ions, so sodium becomes positively charged, chlorine becomes negatively charged, and those opposites attract. Good. Okay, so last lesson we looked at how we carry out genetic engineering and the steps involved in that. Today we're going to look at much more at the why we do it and indeed whether we should be doing it. And we're going to start by looking at a little story that was in the news last year all about genetic engineering. The first part of which is this, which sounds like good news, or at least exciting news, but it was followed a few days later by this, which sounds less than ideal, and then finally by the inevitable this. Okay, all of which is to highlight some of the problems with genetic engineering. If you read into this story more closely, the ethics and the morals of it are incredibly murky. The scientist carrying out the modification of the children was doing it with good intentions, thinking that they could cure HIV, but they did it without really telling the parents exactly what they were doing and really using an awful lot of unknown science. All of which is resulted in the outcome being that really human genetic engineering and modification is way off in the future, and the scientific community came out quite strongly after this story saying this isn't something we're ready to be doing. It's far more complex, modifying and engineering the genome and the genetic information of a big complex organism like humans, as well as all the ethics attached to it around whether we should be doing it, than it is for some animals like the glowfish we looked at last lesson, or what we're going to be looking at today is plants, okay? So we're going to look at an example today of some genetic engineering and modification which is out there in the world now, and there is a debate as to whether we should use it or not. That product that we're going to look at today is called golden rice, and this little video here is going to talk us through why we made it before we come back here and discuss whether we should and whether we should be using it. Okay, so to realise why golden rice is so desirable, let's have a little think about Bangladesh. Bangladesh is a country that eats an awful lot of rice. It provides a staple of their diet in a country that can't grow an awful lot of food except for rice. It grows very well there. But rice is very low in vitamin A, which is an incredibly important vitamin for lots of different things. And a vitamin A deficiency leaves us with a weakened immune system, which means we're more susceptible to disease, and it can also damage your eyesight, even making you blind. Happily, carrots provide a natural source of vitamin A. They're mega rich in vitamin A, it's just that countries like Bangladesh struggle to grow them easily, and so they're really expensive and not that accessible to most people. So what scientists have looked to do is genetically modify rice to contain that same gene for vitamin A production. And so thinking back to last lesson, It's just a case of isolating that gene, cutting it loose using a restriction enzyme. That's the gene for vitamin A production. That gene can then be inserted into the genome of rice using bacteria as a vector and using a ligase enzyme to stick it in. And if you can't quite remember this process, go back and watch the last video. What this leaves us with is golden rice. That's rice that's rich in vitamin A, and it solves this vitamin A deficiency because it grows just like normal rice and can be harvested and cooked and just adds extra vitamin A. However, this isn't without its controversies and its problems, as we'll look at in a moment. Good. So golden rice is out there right now. It works, we've been able to make it, we've been able to grow it, but there's still a lot of resistance and discussion about exactly whether we should use it or not. And all the problems associated to whether we should be using golden rice apply to genetic engineering in general. And you need to know about some of the pros and cons and the reasons for and against this. But ultimately it's up to you to form your own opinion on this. And as the future generation, it will be very much you guys that determine how big genetic engineering is in the world, because all products are about whether the consumer wants it or not. If genetic engineering makes money, then it will be here to stay. If people don't buy it, they don't want to engage with it, it won't make money, and so it will very quickly fall away. So let's take a look at some of those pros and cons. So let's start then with the positives of genetic engineering. And the main one is that we're able to remove diseases. Things like diabetes, even things like cancer, that are linked to our genetics could be cured forever because we can just remove those faulty genes through genetic modification. And as we've just looked at with golden rice, genetic modification could allow us to feed all the people in the world, particularly those poor people that currently struggle, because we can grow more food, and we can grow food that needs less resource, needs less water, needs less soil quality. And ultimately all of this will allow us to live longer. We can remove the genes that cause our death, that cause us to age, as well as feeding us more. Looking at the negatives then, the major one is it right to do this? Religious people would argue that we are playing God when we genetically modify creatures, and that we are causing issues with the overall balance of the world by creating organisms that shouldn't be there. And as we looked at right at the start, this doesn't always work, and we can create defects, we can create problems that might reduce the quality of life. And all of this limits the diversity. By making something very specific for us, it means there's less natural diversity, and it's an expensive process too. And the final one is that there might be unwanted side effects to all of this, things that we haven't considered. So let's have a look at this 6-mark question now. This is a particularly tough 6-mark question, and we'll talk a little bit about some of the factors around it, because this is one of these 6-mark questions that brings together a few different elements from this topic that we've just been looking at. Okay, so this is a tough 6-mark question which brings together a few of the things we've looked at in this unit. So it says that BT corn is a genetically modified sweet corn plant. The plant produces a poison which kills insects, and that this means the farmer no longer needs to use insecticide. Some people are concerned that insects may become resistant to the poison. Explain how these insects may become resistant, and then discuss if BT corn should be produced or not. So this first bit about insects becoming resistant, it's not about genetic engineering. What it's really about is evolution, and being able to explain a little bit of that process there. So why will plants become insects become resistant? Well, eventually they're going to adapt. Insects will have a genetic mutation for resistance. Okay? Mutation for resistance. It might not happen immediately, but at some point it will happen. And when that happens, only those with it will survive. and if they survive, they'll pass on that gene. Okay, so this is evolution. They've all got that gene now, or have the potential to have that gene. So over years, all will be resistant. And because it's not said anything about evolution or natural selection, make sure you say that. This is evolution or natural selection, whichever you prefer. So then you've done the first part of it, and the last bit is discussing whether it should be produced or not. And this is quite tricky. I would say just go for a simple pros and cons. So pros, reasons for, and it's fine to write like this. Well, the reasons for it means more food for people. That's the main reason we're doing this. You get to make more crops, and it means less expensive and harmful insecticide. Okay, which is a real bonus. Insecticide's not that good for the world. However, we need to be saying at least a negative when it says discuss like this. However, and the big problem with this will be that insects dying will disrupt the food chain. You could talk about any of the negatives we've just looked at, but that's the one that goes nice best here, I think. And then you have to, for your final mark, come up with a conclusion. Say a point as to what you think. In conclusion, I think. And this is up to you. You can say whether you think they should do it or not, whether they should use BT corn. There's no wrong or right here. It's what you think's better. Is it better to feed more people, or is it better to avoid this knock-on effect in the environment? Great, so that's us done for today. Next week's lessons are going to be ever so slightly different as we approach the end of term, so hopefully that is good. There won't be too many more of my cringe YouTube videos for you to be watching. Until then though, have a great week.